Today we are going to discuss about Schroedinger wave equation. Actually, it gives or it describes wave nature of particle in mathematical form. For that, Schrodinger has connected classical wave mechanics with the de Broglie wavelength concept, in which there are two types of equations: time-independent wave equation, time-dependent wave equation. So, in this class, we are going to discuss about time-independent wave equation. For that, Schrodinger has assumed a particle which undergoes motion, and during that process it has wave nature. For that, he has referred classical differential equation, which is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, which is equal to 1 by v square into dou square psi by dou t square, in which where v is wave velocity, psi is wave function. And for this can be simplified as del square psi, which is equal to 1 by v square dou square psi by dou t square, which means these are all del square, and this is equation 1. And the solution for equation 1 is psi of x, y, z, t, which is equal to psi naught of e power minus I omega t. Since psi is equal to psi naught e power minus I omega t. Now, differentiating equation 3 with respect to time, we will get dou psi by dou t, which is equal to minus I omega psi naught e power minus I omega t. Differentiating dou psi by dt with respect to time, then we will get dou square psi by dou t square, which is equal to minus I omega into minus I omega. Differentiating this equation with respect to time one more time, we will get minus I omega psi naught e power minus omega t. So we will get I square omega square psi naught e power minus omega t. Now here I square is minus 1. So that we can get dou square psi by dou t square is equal to minus omega square. This is equation 4. Now, if you compare equation 4 with respect to A, then we will get del square psi is equal to, or else instead of dou square psi by dou t square, we can substitute omega square psi. Then you will get this. And if you rearrange this equation, del square psi plus omega square by v square into psi equal to 0. And we know that angular frequency omega is equal to 2 phi nu, and 2 phi nu can be written as v by lambda. By rearranging this, we will get omega square by v square is equal to 4 pi square by lambda. Substituting omega value here, then we will get del square psi plus 4 pi square by lambda square into psi equal to 0. According to de Broglie wavelength equation, lambda is equal to h by p, where p is momentum, so we can write this as h by m into v. Now, instead of lambda, we can get, or if you substituting lambda value, we will get del square psi equal to 4 pi square, and this is h square, and m square v square and psi equal to 0. For a particle to get to have a wave nature, it should be accelerated through a periodic potential field. For that, the total energy E is equal to V, that is potential energy plus kinetic energy, so V plus half mv square. Now, rearranging this equation, we will get E minus V is equal to half mv square. Okay, if you rearrange this, we will get 2 into E minus V equal to m into V square. For sake of simplification, this equation is multiplied by m in both sides, so we will get 2m into E minus V into m square V square. Now, substitute the value of 8 in equation 7, that is instead of m square V square, we can substitute 2m into E minus V, so that we will get del square psi plus 4 phi square by x square into 2m into E minus V into psi equal to 0. And here, multiplying this, we will get del square psi plus 8 phi square m by x square E minus V into psi equal to 0. This is Schrodinger time independent wave equation.